In the previous video, we discussed the Rolle's theorem, question number 1, 2, and 3. Now, in this video, we have to complete the rest of the questions for satisfying the Rolle's theorem and finding the value of C, that are question number 4, 5, and 6. So, starting from the question number 4, f of x is equals to 1 minus x square over 1 plus x square, and we have to check its validity in this interval minus 1 to 1. First of all, you have to check that f of x is continuous at this interval. Now, again, in this question, in this function value, you have a fraction. The fractions have mostly some discontinuities as some values. We have to check whether this fraction is discontinuous in this interval or not. Now, the fraction becomes undefined when this denominator becomes equals to 0. Now, in the denominator, we have 1 plus x square. Whatever the value we put here in this x, we can't get minus 1. If on any value we got minus 1, then 1 minus 1 can be equals to 0. So our denominator becomes 0 and the function will become undefined. But here in this interval, you see this is x square. We can't get any negative answer here. So our this function is continuous in this whole interval. So f of x is continuous on closed interval minus 1 to 1. Now, the first postulate is satisfied of Rolle's theorem. We have to check the second postulate. For checking the differentiability, we have to calculate the derivative of this function. F of x is equals to 1 minus x square over 1 plus x square. F dash of x, derivative, the square of the denominator as it is, and the derivative of this numerator. The derivative of this numerator will be minus 2x, then the formula negative, then this numerator as it is, and the derivative of denominator is plus 2x. Simplify all these values, multiply the brackets and open, and we will get minus 4x over 1 plus x square whole square. Now we have to check that whether this derivative value is continuous on this interval or not. Now again you see this is a square term. Whatever the value you put from here in this x, you will always get a positive answer. And 1 plus any positive answer will again give you a possible positive answer. Now, if we got here minus 1, then this 1 minus 1 can be equals to 0. Then our function will become undefined. But here you can't get minus 1 here. So, it means your function is differentiable on open interval minus 1 to 1. Now, put this value a and b. This is our a is minus 1 and b is 1. Put these values in the function. F of minus 1 will give you 0 and f of 1 will also give you 0. Since both are equal, so that means our third postulate for the Rolle's theorem is also satisfied. So we'll say, so Rolle's theorem is valid. Now we have to calculate the value of c. For that purpose we need f dash of c equals to 0. Now put c in place of x here in this derivative. Put c in place of x here. We get minus 4c over 1 plus c square whole square equals to 0. Now rearrange the values. This denominator will become multiply with this 0 and you will get only minus 4c equals to 0, and this implies c equals to 0. Now we have to check whether this c in this interval or not. Now 0 belongs to this interval minus 1 to 1, so it means the c belongs to this interval. So it means c is equals to 0 is our value for this c. Now moving on to the question number 5. Question number 5 is f of x equals x into x plus 3 e raised to power minus x over 2, and your interval is minus 3 to 0. First of all, this function is continuous, and this whole interval we will get none of the undefined answer on any of between this interval. So f of x is continuous on this closed interval minus 3 to 0. Now calculate f dash of x. For calculating f dash of x, these are three functions in multiplication with each other. I will convert them into multiplication of two functions. So for that purpose, first of all, simplify it. X into x plus 3 e raised to power minus x by 2. Multiply x inside, we will get x squared plus 3x into e raised to power minus x. Now we have multiplication of two functions. We can easily find out its derivative. First, I will take the derivative of this function, 2x plus 3, in the second function as it is. Then plus first function as it is, and the derivative of second function, e raised to power minus x by 2 as it is, and the derivative of minus x by 2. Now its derivative will be minus 1 by 2. Now simplify all these values. I am taking this e raised to power minus x by 2 as common so that I can easily simplify it. Whatever I will get inside, 2x plus 3 plus x squared plus 3x into minus 1 by 2. Now simplify all these values. E raised to power minus x by 2, take the LCM. You will get 4x plus 6 minus x squared minus 3x. Now simplify all these values. We will get minus 1 by 2, e raised to power minus x by 2, and inside x squared minus x minus 6. Now our interval was, open interval was minus 3 to 0. Whatever the value you will put between these values in this function, derivative function, you will get none of the undefined answer. So it means f of x is differentiable. F of x is differentiable at this open interval minus 3 to 0. So your Rolle's theorem is satisfied if f of minus 3 and f of 0 becomes equals. Put the a value minus 3 in place of this x here and get the answer, f of minus 3. So it will be 0, and f of 0 will also give you 0. So since f of minus 3 is equals to f of 0, so it means Rolle's theorem is valid. Now we have to calculate the value for c. For calculating the value for c, we need to put c in place of x here in derivative. F dash of x was equals to minus 1 by 2 e raised to power minus x by 2 x square minus x minus 6. Put in place of x c. We will get minus 1 by 2 e raised to power minus c by 2 c square minus c minus 6. Now make this f dash of c equals to 0. We will get minus 1 by 2 e raised to power minus c by 2 c square minus c minus 6 equals to 0. Now minus 1 by 2 cannot be equals to 0. Also this cannot be equals to 0. It means this function is equals to 0. C square minus c minus 6 is equals to 0. Factorize this. When we will factorize this, we will get c minus 3 into c plus 2 equals to 0. We will factorize this by converting it into the 4 terms. Or you can also use the quadratic formula to find the value of c here. You can find the value of c through any method. I have find this factorized form through the factorization. So now either c minus 3 is equals to 0 or c plus 2 is equals to 0. So it means c is equals to 3 and c is equals to minus 2. Now what your interval was? Open interval, minus 3 to 0. You have to check which value lies in this interval. Now draw your number line. You see here is minus 3, minus 2, minus 1, 0. Your interval is between these values. Now 3 does not belongs to this interval. It means we will not take the c value. Minus 2 belongs to this interval. So your c is equals to minus 2. That belongs to open interval minus 3, 0. Now moving on to question number 6. Question number 6 is f of x equals to 2 plus x minus 1 raised to power 3 by 2 on interval 0 to 2. Now again you have to check the interval, like you have to find any value that will make this function undefined. None of the value from this interval can make this interval undefined. Mostly we get undefined values in fractions, in square root, or in functions that have a negative value in the square roots, or the 0 in the fraction form, denominator. So this is a straight line function, like a polynomial type function, so we get none of the undefined value in this interval. So f of x is continuous on this closed interval 0 to 2. Now find the derivative f dash of x. When we will find the derivative, this constant term will become 0. Then power down, power minus 1, and then without power derivative will be 1. This will give you 3 over 2 into x minus 1 raised to power 1 over 3. Now you see we got a fraction here. The fractions sometimes get some limitations, like this denominator cannot be equals to 0. Now in this interval you see we have 1 in this interval, and if we have 1 minus 1 here, then our denominator will become 0 and our whole fraction can be undefined. So x cannot be equals to 1. This x, if we have x equals to 1, this x makes the function equals to undefined value, and this x is equals to 1 is included in this interval. It means our function is not differentiable. F of x is not differentiable on this open interval 0 to 2. So we will not proceed further and we will stop here, and we will say as one of the conditions of Rolle's theorem is not satisfied, so Rolle's theorem is not valid and we cannot find out the value of c. I hope you understand these 6 questions regarding the Rolle's theorem. Next to this questions, we will do the mean value theorem that are related to the next questions. For more videos and updates, you have to like and subscribe the channel and do share it with your friends as well. Thank you so much.